shalt not covet thy neighbor's paper, nor anything that he has. I love math.
Hey, this is Mr. Eng going over the stats quiz number 2, 3.1 to 3.6, which is all of these topics right here. And this was taken on September 20th, 2022.
It's time for game plans.
Questions 14 to 15 refer to the following experiment. The mathematics department wants to see if the use of a software program will improve scores in geometry. The department has decided to set up a small experiment with 10 sections of geometry, 10 classes. 2 teachers have volunteered to participate and use their sections of geometry. Ms. Smith is going to use software alongside existing classroom materials, while Mr. Jones is going to use the current classroom materials only. Each teacher will use 5 sections of geometry, time periods 1 through 5, and students will be given a pre-test as well as a post-test at the end of the course. What are the treatments to this experiment? Well, it's verifying it's an experiment because they're breaking them up into 2, right? Those who have the new stuff plus old stuff, and those who just have the old stuff. The treatments is, what do you give them? What do you give the students? Well, what you give them is the software or no software, because both of them are given a teacher. That's the same. Everyone's taking the post-test. Everyone's taking at the same periods 1 to 5, and all those students are taking it. So the only thing that differs, or that's different in both of those, with Mrs. Smith and the other guy, is the software or no software. What variable is confounded with the treatments of this experiment? So we talked about confounding variables. What can help students get better test scores? Well, we want to test the software, no software, but it's the teacher. Miss Smith might be an awesome teacher, and that's why her students score better, not because of the software, no software. The next question, sorry, the numbering was all crazy. A political polling group is interested in learning about the proportion of registered voters who favor a particular candidate for the mayor. Their sampling plan may have introduced bias or help you lean towards a direction or not being fair if individuals were selected randomly to participate from a list of city registered voters. This one seems fair, so this one's unbiased. Every 50th person on the list of registered voters was contacted and asked to identify who they would vote for the upcoming election. Every 15th. This is a systematic way of getting people, so I would say this is unbiased. Select a list of registered voters was first separated into 2 lists, one of females and one of males, one of females. Then individuals were selected at random from each of these 2 lists. So this one is called stratify. You broke them into 2 groups, males and females, and then you randomly pick. So that one I would say is unbiased. A survey was mailed to all registered voters, and those who returned the survey made it make up the sample. So those who return it, those are the volunteers. They have a strong opinion. So that would be more biased, so that the answer is D. Which of the following is always problematic in a design experiment? So experiment means you have 2 groups. No placebo is used. Well, sometimes you want to just place 2 different items, so not necessarily a placebo. Systematic sampling is used instead of random sampling to select subjects. Okay, that is problematic because, well, at least systematic is a type of random sampling, so that's okay. So A is okay, B is okay. Subjects are not randomly assigned to treatments. Oh, I think it's that one. No control group is used. Remember, the control group means they get nothing. But you don't necessarily need that. Volunteers are randomly assigned to treatments. That's good. So what's problematic is C. You can't just have all your friends in one group, and maybe you're like the track team, and then we do an experiment who can run the mile the fastest. Well, of course you are, because you weren't a random.
Alright, we need to figure out that there are 863 seniors at a large high school. Explain how you would use a random number table to select a random sample of 20 students. Well, I would use the acronym DARE. Whoops, that one's too big. Because there's 863, I would use the digits. Use digits 001 to 863. A means to assign, and we're going to assign each senior a number. I'm going to, on the repeats, I'm going to skip these. And then we're going to end when you have 20 seniors. Okay, that was out of 4 points. Use the random digits below. Select your first 5 participants using the scheme in A. Okay, so the first one is 569. That one works. So 569 is our first student. Then I have 647. That is between the numbers 001 and 0863. 082. That one works. 735. Okay, this one does not work in pink here. That's 916. That's too large. And then 378. So there are my first 5 participants.
Yeah, 1 and 1 is 2, and 2 is 4. 3 and 3 is 6, so now let's try some more. 4 and 4 is 8, and 5 and 5 is 10. 6 and